Here we go.
Ooh, I think here we go. I think we're ready, gentlemen. And astronomy freaks all over the Southland here. It is the weekly vlog podcast underway that we call the SBAU Astro Hour. We have members on the screen. They gather together every Monday morning, 11 to noon, from our man caves and telescope observatories in the backyard on Zoom. We have the members of the Longtime Telescope and Astrophysics Club, which is filling that hall at City, what is it, our Museum of Natural History every first Friday. My God, we had a great time Friday night. Santa Barbara's Astronomical Unit. I'm Ron Herron as your host, proudly. Going to call up the gang here in a minute. This is episode number 116, going into our third year of broadcasting this or telecasting, whatever it's called. It's from May 8th, Monday morning now, through the 14th, I do believe, which will be next Sunday. This week, we're going to try to talk about some blue stragglers that Hubble has zeroed in on. What the heck are blue stragglers in the Milky Way? We'll find out. Somewhere out there near or in the Summer Triangle, and easy to spot global cluster M13 we're going to focus in on, sometimes called, I think, the Keystone of Hercules. And our moon's approaching fourth quarter that soon. Seems to me it was full on Friday night as I went back out into the parking lot after that great speech. Anyway, it's leading Saturn, where you can spot its biggest moon, where we're going to go visit Titan someday. And apparently, we're going to tell you how many moons Saturn now has. You're not going to believe the latest breaking news. We're going to check a dwarf planet out in the asteroid belt, Ceres. It's up there too. And a supernova remnant in a satellite galaxy. Let's meet the gang. Hello, President Jerry.
Good morning. Good morning.
Jerry Wilson, married to Pat Forgy. We're there in attendance at our own little gathering, our May, what was it, the 5th, Cinco de Mayo, with a full moon outside. And we had a young man named Joseph Farah, an LCO, give us a great, funny talk. Here's Chuck McPartland. He was there, married to the other Pat. Chuck is our outreach coordinator guy, and he's stunning. Wife Pat, merchandise manager. We're in attendance. We have Tom Whittemore, who edits our newsletter.
Morning.
And he's
Morning.
on board with us, retired former Westmont College science instructor, man in the lab. I'm not sure. We got Bruce Murdoch on the screen, but I don't think his sound works. Let's see if you can talk to us. Bruce, are you with us? Oh my God. He's doing his exercises. Uh-oh, there's his wife. Bruce is married to Bonnie. Tom Whittemore is married to Maureen.
That's his daughter.
And president and outreach have
Yeah.
Pat. I have nobody. Are you there, Bruce? Thought I was hearing you.
He is here. I muted him because it sounds like someone's scraping dishes in the background. I guess he's having trouble with his sound, but now it's up
Don't do
to
that,
him to
Murdoch.
unmute.
All right. Well, we may go ahead with the silly stuff, our silly science cartoons, which we start the show to get everybody into a great mood, because President Jerry loves them and we love getting them. He forwards them to us. Speak whenever you're unmuted there, Mr. Murdoch. Meantime, we got a handful of goodies. Let's go to the screen and what is this? I don't remember this one. Oh, yes, I do. The astronaut from New Zealand is out there. He becomes the first person to bungee jump into a black hole. My God. And
It's not going to go well.
Yeah, I can tell, right? He would spaghettify along with this, the rubber. And any of you have done a bungee? I don't think any of us have.
I have. In New Zealand.
Oh,
Really? Well, that's the one.
At the home of Bungee, Kauaru Bridge.
Well, you must have a fear of heights like the rest of us, don't you? For Christ.
Yeah, you definitely get a feeling for that.
Doesn't have a fear of cats. That he just has an allergy to them, and yet that cat may show up. What is this? Oh, this is our drawer. This is I got one exactly like this.
a kitchen drawer.
Yeah. Cultures in class, we share one thing in common, just stuff. Okay, oops, what is this all about? NASA scientists have just isolated a sound just prior to the Big Bang that sounds something like, oh my God, what have I done? Oops, Father Time tripped over himself too. You want to blow that up one time? And
Yeah.
tell us what the heck Korgalag is? Korgalag?
Some mythic beast from H.P. Lovecraft's books, maybe.
Okay.
At last, the planets are all aligned, and Korgolag will rise again. Nothing happens.
Except there are
Hey, big
8
guy,
planets.
what's he gets on the phone? Hey, big guy, what's the holdup there? I don't see Pluto in the line.
Yep.
It's not a planet. Get over it. It's still a planet to me.
Now that's an extraterrestrial dog because it's got horns, or
I think it's a supernatural dog.
a supernatural dog. Yeah, there are people that take that very personal. All right, there's the backyard of the Purchase. Oh, this is the big Purchase cartoon. One guy watching as it falls over. Sure, it has a
The
5-star
objective
rating.
lens falls out of his scope.
Oh my God. 5 stars though, but it's out of 5 billion of them. There's got to
And
be
over
more
on the
than
left,
that.
it says it left a black hole in my wallet.
Oh yeah, right. I see that. This is good. All
Can you
right.
hear me?
Yeah, I hear you.
You hear you, but
Good.
it sounds like you got a pillow over your mouth.
I'm at the tire shop getting a new set of tires.
Oh,
But
You're not
my
even Okay.
my cell phone Bluetooths to my car, which is not too far away, so it was trying to work out there. And I finally turned Bluetooth off, and now I can work here.
Boy, that's dedication to the Astro Hour. If you'll call us from your damn tire shop there, Bruce, that's great.
Well,
You want to
I'm
show
just
us
sitting
having?
here waiting. I had a 10 o'clock appointment, and they didn't get to my job until about 11:15.
Well,
okay.
carry it around. Let's watch him put the tire on. What do we got here? We're going to go to
All 4 of them.
is this a deep field? No, where are we here?
No,
Terry?
this is our galaxy over here. It's the core of our galaxy in Sagittarius region. I believe this red thing here is M8, the Lagoon Nebula.
Looks like it, yeah.
Yeah. So anyway, it's in that region, and this is actually where the core of our galaxy is. And it's a very dense star cloud. And in that star cloud, they have managed to, for the first time, isolate stars that are blue stragglers.
A blue straggler. Get a new term here. What
Yeah.
the heck is a blue straggler star?
And this is from the, this is taken by the Hubble, which gives the high resolution that they need to spot this. They've never seen blue stragglers in the core of our galaxy before. Blue stragglers have been identified for about 50 years, I think it was, but in the core and near core of, what are those things? Globular clusters.
Globulars, yeah.
And so what they're believed to originate, there's a couple of hypotheses, but the most likely one seems to be that in regions where stars frequently collide with each other, they can shift their load of fuel about to be burned. And so they can give a false impression of how old they are, because you go by how much of their fuel is burned. And if they get a new load of fuel, it changes their apparent age.
Huh.
So blue stragglers, the name comes from them in that they're hot stars. They're very
They're young.
yeah. Well, this is a little simplification of a Hertzsprung-Russell diagram. This is magnitude, which is how bright a star is, and this is that's absolute magnitude. And this is spectral class. This is temperature, and this is the hot end of the classification. This is the O star. So these are blue, which means that it's very hot. And they apparently are older than, or no, they're younger than what you would expect, where they would expect to follow this branch of the curve. They're out here in their own isolated thing, which makes them an oddball classification.
And what that Hertzsprung-Russell diagram probably was of a globular cluster, showing how most of them had turned off of the main sequence into that giant branch.
Right.
And yet you still have this straggling bunch out here toward O.
Yeah.
But you get the age, you can tell the age of a cluster of stars by where this branch happens on the main sequence.
Excellent. Thank you.
But blue giants or blue, whatever they're called,
Stragglers.
they don't, they're in the Milky Way. So therefore we don't get that shift to infrared, do we? That's got to be far.
This has nothing to do with redshift. Yeah.
And this is absolutely blue, not that a specific line is shifted toward the blue.
Yeah.
And this is the thing that was developed by Annie Jump Cannon or her cohorts of Harvard computers working for, I forget who. But they had noticed they were measuring the color of stars, and they put up they decided that going from red to blue was going from cool to hot. And this is a chart of what's now called the Harvard spectral classification chart. And our sun is a G, which is a white to yellow star. And our sun is about 5,800 Kelvin. And it's right here. These blue stars are type O, and they're over 25,000 Kelvin, much hotter. Some of these stars go up to 60,000 degrees, and that's surface temperature. So this is what happens to these stars after they collide. They get to be a very hot surface temperature star. Let's see if I got another chart on that. No, that's the next thing. So,
but is it only because they're in the center of the galaxy that they're in that condition, or that we call them that?
It's because they're in a crowded environment where you get these collisions that cause that to happen.
Right. On the center of the galaxy in general contains, older stars, and the younger stars are usually out in the wings.
Well, do you suppose they're orbiting fast, even though they may be a distant from a very big, black hole? Or are they?
It's not so much that they're close to the center, it's that they're close to each other. It's a very dense region.
They might be in the bar, right? The bar is a little beehive.
That's the dense region, yeah.
Yeah. Our galaxy core has a central bulge, which is a big, if you look at it from straight to the side, you see above and below the main thing, you see a bulge. And in that bulge, that's where these stars are. And they've just been located for the first time with this study. As they've been seen in other high density situations like globular clusters for many decades now. But this is the first time that they've been able to specifically identify and characterize the same thing happening in the core of our galaxy.
Your talking points said they are lagging behind in their aging as stars.
They're staying young.
They're staying young.
They found the right wrinkle cream.
Oh, we should have been on a planet orbiting one of them, gentlemen.
And Ron, they may not actually be O's if you're in a really aged cluster. They're just anomalously young, because it could be small stars that have collided and it churns up more material, and then they look younger, but they may not necessarily be all the way out to this O level. That would be a very massive star.
Or do those letters mean anything or stand? I know they mean something, but are they a word, like some word that starts with O?
They started out as an alphabetical A, B, C, D, E, F, G when they were trying. I think it was Secchi. Tom, you'd know better how to pronounce that. Father Angelo.
Yeah, Secchi.
Secchi, yeah.
Secchi.
They were trying to characterize stars based on their spectra alone. And they came up with this A, B, C, D, E, F, G, but it wasn't an evolutionary sequence. And now this is kind of more like an evolutionary sequence. Right. So they had to jumble the letters around when they found out what was
gives
going
us
on.
That gives us a new mnemonic to remember them.
Okay, don't be too sexist on this one.
Yeah.
But from now on, we'll know our.
Go ahead, Chuck.
Our star is a G.
It used to be, oh, be a fine girl, kiss me, but I think now that has gone out of favor.
There's actually a Wikipedia page on at least 36 different variations that are more politically correct.
Right. Up in Berkeley, Chuck, it's what was it? Alex Filipenko gives killer midterms.
Oh, that's great.
Yeah.
Alex used to be a member of our club.
Yeah.
We should.
I used to teach out of his book. It's a wonderful book.
We should stage a SBAU class reunion and send him an invitation.
He has come down before when his parents were here, but his parents are gone now, so he doesn't come down. He's too busy.
Yeah.
And now that we have more technology, these classifications were developed in the early 1900s.
Mhm.
The chart has actually been expanded now with different meanings, and added new categories of capital R, capital N, and capital S. And then there's also Q for nova and W for Wolf-Rayet stars,
Okay.
which are
Wow.
not frequently encountered.
Well, the big black hole is called Sagittarius A. Is that a class
No,
all its own?
no, that A refers to the fact that it was a radio source.
And it's not A, it's A star. And
A
it's not a
star.
star.
A star is the black hole. Sagittarius
Right.
A is the radio source, and it turns out
Right.
they're the same thing.
Good.
Okay, but those are the big blue meanies. All right.
Very hot.
Okay.
Very hot.
Now we have a couple of things here. Easy, since I think last Friday was full moon.
Mhm.
So it's up and it's pretty bright, but it is rising a little later each night. So we are getting a slice of night before that. So we can see some faint fuzzy things in the west before they set and before the moon gets up and screws everything up. And so this is Hercules, and this is looking west at
East.
No, that's definitely east. Jerry.
east, sorry.
Mhm.
How would you know? Well, depending on
No,
what you're talking about.
they're right. I just sometimes
I
think
saw
one
them
thing
last
and say
night.
another. So this is the sky for May 10, but there'll be no difference between May 8 and this at 10 p.m. So this is looking east. Thank you.
Mhm.
And in the constellation of Hercules, unfortunately, the moon is near it. And this is the constellation of Lyra. So the object is M13, a beautiful globular cluster. The easiest star to spot, Hercules does not have real bright stars in it. So the brightest star here is Vega. And you can tell when you've got Vega, first of all, it's the only bright star in the area. But it's got this perfect parallelogram right below it. And at the base, right halfway down the base, right in there, there's no dot for it, but right where the hand is, that's where M57, the ring nebula, is. And thanks to, let's see how to get to that. Can you see this?
No.
Your
It
Your
just
arrow?
looks like carbon fiber.
Oh, it's black.
Yeah.
Yeah. You
Okay, let me.
put up the monoliths from 2001.
Okay, now.
There you go.
Okay. So this is courtesy of Tim Crawford, who loves to find these little pathways to aid. He's a wonder at finding things in the dark sky by finding other things and how to get to them.
Mhm.
It's called star hopping, and he's a master of it. So this is Vega. This is where M57 is, the ring nebula. And if you go follow this edge of this parallelogram and you follow it right across here into Hercules, you come to this, the opposite side of this trapezoid from where Lyra is. And about a third of the way down, you can see M13. It's a good way to find it. But once I find this, this is called the keystone. Once I find the keystone, I know right where to look for M13. And it's a very dramatic globular cluster. Now let's see if I can get.
And not related, Jerry, but part of this is that's where the sun is dragging us up to the keystone.
What is it?
That's
Is
where
it
what?
shaped-
The sun is dragging us, dragging all the planets towards the
Oh yeah,
keystone.
we're heading for, our sun is actually traveling toward the keystone, yes.
It's
Really?
called the solar apex.
Yeah. So
Now,
this,
is that parallelogram the keystone or one of the stars
yeah.
in it?
Not the parallelogram in Lyra, but the
It's a rhombus.
trapezoid or rhombus in there we go.
this is the keystone up here. See,
Yeah.
it's shaped like the top, the crowning stone in a stone arch bridge or arch support.
That would be laying on its side, I think.
It is laying on its side.
Right. And yeah, just to show you that Hercules is lying down, that Ras Al Gethi, you see that star towards the bottom right? That means the head of the Needler. So that's
This
the head
one?
of her. Yeah, so he's kneeling, and that's his head.
Yeah. And he's got one foot on the head of the dragon.
Yes.
Yeah. Apparently he has a tail too, but we won't go into that.
Yeah. And Jerry,
No.
I just want to mention, on a good summer night here, lying on our backs, we can still see M13 naked eye.
Yeah.
Just want to
It's
rub it
very
in.
very dark sky.
Yeah.
Tom is bragging about living on a hilltop again. So anyway, he's above all, when the rest of us get dense fog and overcast, he doesn't. So this is M13. Now there's a lot of pictures available of this through the Hubble and stuff, and they're very dramatic. But this is more likely what you're able to see in a small amateur telescope. And it shows the cluster, and it shows a small galaxy, IC 46.
That's a tough one to pull out, Jerry.
That
6207 is easy, but that's a toughie.
Yeah. But this one, NGC 6702, is easier to find visually in a small scope.
Yes.
Afraid you got dyslexic there. It's 6207.
6207, yeah.
Yeah.
You've correctly spotted how I think.
But those are distant galaxies. They're not.
They're way back, way background.
Yeah, but they're not part of the local group.
No.
I don't think so.
Yeah. Yeah, a neat thing, when we set up the scope at Westmont is, summertime, we always show people M13, and often in the 8-inch, 6207 comes right out. And we tell people that, M13 is about 26,000 light years away, but 6207 is a galaxy. And Chuck, is it about 30 million light years out? 60 million?
Sounds like a good number to me. I'm not.
It is out there.
Yeah. Definitely background.
Yeah.
Now
And then
this one
foreground.
is a good.
Yeah.
Go ahead.
What
Well,
is that?
Jerry, Jerry, you were doing the foreground there. Yeah.
Oh,
You're going to do
No,
the
I was-
foreground star. Yeah.
well, I was not going to name the star. I'm going to tell you that from a astrophotographer's point of view, this is a very nice and convenient guide star for your scope.
Okay.
There's
think
one
that-
on either side, right? 2 9th magnitude stars flank it.
Yes. Either one will do.
It has that 4-point cross on it. Does that mean it's close? Closer
No,
than
that
the
means
other?
it's taken with a reflector telescope and it's
Yeah.
bright.
And
Yeah.
by the way,
Those are-
guys, Jerry, I was just going to say, I can credit M13 as getting me into astronomy when I was a little kid. My brother Paul, when I was young, borrowed a 6-inch homemade telescope that had as a counterweight an agitator. And he showed me this, and I never forgot it. And that kind of led me to chase stuff like this.
But this is
Right.
definitely a globular cluster. There are
Yes.
other kind of clusters.
Mhm.
Yes,
Like
the
a
first
globe.
time I ever saw it was the first globular cluster I saw with my homemade 6-inch f8
Yeah.
Newtonian. And the first time I spotted it, I did that Steve Martin thing. Ooh. 2 seconds later, So,
Well,
okay.
we
Now
usually have-
this one shows a feature, an optical illusion. This is M13 in 2 pictures. This one has what's called the propeller drawn in over the top of it. And so you know what you're looking for by looking at this. And then you can see that there are dark lanes in the
Mhm.
cluster. And that formation is called the propeller. There's also a lane over here that I tend to think of as the Allen wrench. But there are dark lanes in it, and your eye will try to find patterns, recognizable patterns. And this is one that you see, but you only see this visually, usually, or this is a photograph, you obviously see it in here. But if you take a real deep photograph of it or something with the Hubble, this is completely washed out by all the dense stars.
So those are pieces of dust and gas forming a line?
Most likely it's just an accidental paucity of stars.
Really? Okay.
And an observer named Smith, I think it was in the 1800s, thought that the sense of the stars in M13 had almost a spider-like visual. It's pretty neat. Smith was his name.
Mhm.
I think he's responsible for the wild ducks too.
Okay, okay.
Oh, he's to blame.
Yeah.
So there are a number of streamers and trailers that go out
Yeah,
from this
yes,
that could give
yeah.
you the impression of spider legs.
That's it. Yeah, that's
Yeah.
what he's.
So the picture on the left, gentlemen, has what looks like a paper clip sitting there. Is that man-made?
That's the
and-
propeller. That's the
the
drawing
propeller.
of the propeller.
Yeah.
Yeah, if you take that and look at the right, Ron,
Oh, I see. Okay.
Barry said the paucity of stars there looks like a propeller.
Okay. I only see I only saw, now I see the other two blades. One at
Mhm.
7:30. Interesting.
Yes,
Okay.
yeah, one about noon. And
Maybe
then
it
one
is a
later.
propeller. Maybe that sucker's being propelled through the Milky Way by a propeller.
Nah,
Works for planes. I love it. Thank you.
Now remember, these globular clusters orbit our galaxy's core in a big sphere. They're not in the plane of the galaxy necessarily unless they're passing through.
Mhm.
So it's
Whereas-
like an Oort cloud of clusters around the galaxy.
So all those stars that are in there, there's got to be thousands, are going around and around inside the ball, the cluster, as well as the whole damn thing moving. It's an
Yes.
extra dimension, isn't it?
Yeah.
Yes,
yes.
like a beehive in there.
And I
Mhm.
think the current estimate is between 1 and 2 million stars in this
Right.
cluster.
Yeah, there's a lot.
Wikipedia has between 10,000 and 100,000 stars, I noticed, but I have read what Chuck just said, that it's estimated now to be over 1 million.
Right, and Tim Crawford's line at all the star parties is somebody hired a fellow to count all the
To
stars.
count them, yeah.
Yeah.
And the toughest part is when you have to quit when dawn is coming and then remember where you were for the next night.
Yeah. You just need a marker.
Yeah.
Okay.
I got to tell you, gentlemen, when they track the Earth, the track of the Earth going around the sun, and the sun and all of us going in a certain direction, it looks like a corkscrew in space. Those damn stars in that what is it, M13?
13.
Can you imagine what their track looks like? All right, fascinating stuff. Just a beehive. Okay, are we on to something new here? Didn't
Yes, we are into,
Looks like Ceres and Nebula.
yeah, Ceres is this red spot right here, and the tail of Leo the lion. Leo, this is the
Mhm.
big sickle of Leo. There are two objects in here that Astronomy Magazine called our attention to. The other is M99, which I seem to have lost track of here.
It's up and left of Ceres.
Oh, right there. Yes. Okay.
Mhm.
Thank you.
Yeah, and the Virgo group.
Yeah.
Well, now Ceres is a large asteroid. It's a dwarf planet. Is it just?
It's a dwarf planet. Yes.
Okay, and it's in the asteroid belt. That's within our solar system. But
Yes.
it's not red in the picture. We just made it red to designate it as a rock, right?
That's what this planetarium software, that's the false color it chose.
Okay.
So it's round. It's made apparently a large part of ice. We visited it and orbited it and taken lots of pictures of it. It has a very, very bright, almost searchlight bright spot on the side of it, which you can see with very large. Well, you couldn't see it till we got really close to it in the spacecraft. What it was.
They had detected it with Hubble.
Right. Yes, because it moves around, it rotates.
Yeah.
But it's apparently salts left over from a volcano of salty water that erupted there and left all these salts deposited on the surface. It's got a mountain of almost pure ice on one part of it. It's a very dramatic look. It looks like a big trapezoidal prism sticking up. It's a very interesting world and apparently a lot of water on it.
Otherwise, it's several hundred miles across, so it is a sphere.
I think it's 600 kilometers across.
Okay,
Oh.
it's about 450 maybe.
Yeah, something like that. So, and then M99. Now, this is a very rich region of the sky. This is in the west in the evening.
Yes. Mhm.
Well, I can't drag that. Oh, there. Okay, this is again May 10th at 10 p.m.
Oh,
So,
I was just going to mention, Barry, the two stars that bracket the this wonderful cluster of galaxies is Denebula Vendemiatrix, which means the grape gatherer, Vendemiatrix.
Yeah, this is
Vendemiatrix, yeah. So
what Tom said.
Yeah, Vendemiatrix. Yeah, grape gatherer. So when the sun is near this star in the fall, the Romans used to gather their grapes for their wine. So that's why it got that name.
Really?
Oh, okay.
Mhm.
Gather ye grapes while ye may.
Yeah.
Okay, so back to M99. M99 is a very interesting galaxy. Let's get a little bigger.
Here it is. Spiral
Now, this
arms.
galaxy
Two big ones.
Yeah, face on, huh?
is called a grand design spiral galaxy.
Yeah.
Approximately 15 million parsecs, 50,000 light years away. First seen by Pierre Méchain in March 1781.
Yeah. The Messier scooped it up.
Yeah.
Yeah,
Well, yeah, that was
yeah,
Messier's
he
assistant.
put it in his catalog.
Yeah.
He was Messier's assistant. So he and also, I think Lacaille.
Yeah, Lacaille. All French. Yeah.
Wait a minute. You said it's 50,000 light years away?
Yeah.
50 million. 50 million.
Million.
Oh,
A million. Yeah, yeah.
I
Yeah,
might have
yeah.
said light years, but I mean thousand, but I meant million.
Yeah.
Don't listen to what I say. Listen to
Well,
what I mean.
I was excited for a second there. We might be able to go to it if it's that close. Yeah, right. Be damned.
So it's referred again to a pure spiral shape with loosely bound arms. It's inclined 42 degrees to us, so it's slightly foreshortened. There have been three supernova and one nova discovered here. 1967, 72, 1986, and a nova in 2014.
Nova doesn't sound as big or splashy as a supernova.
Yeah.
Oh, this is the nova one?
Well,
It's
is it a
big enough you can
kilonova?
spot. Yeah.
Hypernova? There's all
No, it
kinds.
was just a nova. Probably, I would say that's probably discovered by Hubble, because I don't think that's something you'd see in a backyard telescope.
Huh. Is it barred? Is there a bar in there or just a circle?
No, there's a very, very small bar, but it's considered a classic spiral, so it's not really considered a barred spiral. It would have a B in its classification, which it doesn't. It's classified as S, capital A, S, small e. So no bar in it. It is right on the verge of being what's called a starburst galaxy, in that its star formation activity is usually is measured to be about 3 times what an average galaxy of its size and class is.
And you see all those pink spots there. That's where that stuff's going on. Those are like the Orion Nebula, where that's a active star forming region.
Right. And you see the older stars, Ron, are in the middle. See, they're yellow.
Well, where it's white, there's got to be a big black hole in there. Sure.
Probably
I
is.
wonder if they've ever programmed a computer which can, make the two colliding galaxies get all weird. I wonder if they can make one of these things go backwards so as to see where the stars go, since they're being stretched, as it turns slowly, and they used to be more conglomerated together without arms as much, wouldn't you say? Or
Well, yeah.
at one time, maybe they were elliptical. not
Anything you
even
can run a
turning.
simulation on, you can run backwards. So
I mean, it's just like twisting, the rubber band on one of those airplanes
Well,
that we used to fly.
these aren't physical structures, Ron. These are like traffic jams, so they don't necessarily wind up or spread out.
They don't? They go get
No.
longer and
No.
I'll make a special paragraph next time on galaxy rotations
Yeah.
with pictures.
Yeah.
So
Yeah, if you look
this-
real carefully, you can see other very, very distant galaxies. in the
yes,
same-
there's a lot of things in there.
Yeah.
One right there. Now, this is on the very edge of the Virgo cluster. And so the article claims that it is moving into the intergalactic region out of the cluster, and it's suffering from ram pressure against the intergalactic medium. Much like Voyager 2, that's experiencing, it's passed out of the shock wave from our sun's solar system and getting into the environment of interstellar space. This one is
Yeah.
getting into the environment of intergalactic space. And the spiral structure is changing, being compressed on one side, and the high star formation is believed due to the dust being pushed together by the ram pressure of this thing escaping from the Virgo cluster.
Hmm.
So
And
a
you
lot of
can tell-
interesting physics going on in that.
And you can tell this photo was taken with an RGB, first a red, green, and blue filter, and maybe even a luminance filter, and then combined, because it looks like there was an asteroid or a satellite in the lower right corner that passed through while they were doing their red filter image.
Yeah, I saw that. Yeah.
But we
Good
can
spot.
see that. We can see this with the naked eye as a little dot, or do we need a?
Oh, no. This
This
is,
You
is,
need
I
a
think,
telescope.
Yeah, I think
Just
this is a 9th magnitude object. Did I put that in there?
I mean, the
Anybody-
fact that Messier.
Anybody know what kind of a telescope old
It's-
Charles Messier had? Did he have
It's
a
10th. This is a 10th magnitude object.
Yeah.
He
Oh,
had a 3-inch refractor.
Yeah.
and he could see it like we're seeing it right now?
No.
Oh, no.
No,
What
they-
he saw
Bubble
was-
image.
What he saw
was
was how
looking for
this star looks.
Yeah, he was looking for comets, Ron.
So he didn't even know he discovered galaxies.
No,
Right.
Mhm.
Wow.
they didn't even
They were
know what
just fuzzy.
galaxies were. And he
Right.
couldn't see the spiral structure. The first person to see the spiral structure of these things was, who was it? Lord Ross?
Lord Ross in M51.
Yeah.
Yep.
Well, well, I suppose they believed him when he when he was,
He invited any skeptics up for a look, I understand. So,
but he couldn't take pictures of it.
no.
No.
Didn't have photographs by it.
But he had a 78-inch scope. So, it's got a fairly bright image.
Mhm.
The old Messier just categorized things he saw, and they were all the same thing to him, I guess.
They were only categorized on the fact that they didn't move from night to night.
Oh, gotcha.
He was looking for comets.
And he padded it with things like the Pleiades to get elected to the French Academy of Sciences. So,
Well, Whittemore comets do move.
yes.
Yeah.
And so if
that's
this thing
why
didn't move, he knew it wasn't a comet.
Oh, I
Right.
see. Okay,
Because
gotcha.
you had to look at for a comet, you had to look at it one night and remember it. Then you had to look at it several nights later, and if it moved, then it was a comet. So he made a catalog of the things that don't move, so he wouldn't waste any time coming back and looking at them.
I gotcha. But now these distant galaxies wouldn't move at all with a parallax of going around the sun in a year either, would
No.
they? They'd stay in the exact same
Nope.
spot. Wow. Fascinating stuff, Mr. President. Are we
Okay.
plunging ahead?
Again, on May 10th at 10 o'clock at night.
This is what it looked like. Look for
Yeah.
the red one.
Yep. Yeah, I was going to mention this too, Jerry, that I was looking at Mars just with my eyes a couple of weeks ago. It was right dead center in Gemini. And now it makes this nice little arc with Castor and Pollux. You get a sense of
Oh,
color.
yeah, you're talking about this there. Yeah.
Yeah, Mars there. Mhm.
Well,
Used to
now-
be at the belly button. Gemini.
belly button. Okay, what's the red lines?
The red
His
lines are
Just
just, they're just stick figures for representing these different constellations. These blue lines here, these faint dotted blue lines, those are the boundaries, the official boundaries of that constellation. So I guess they had some boundary wars here.
Yeah, and you can see all this facing west around 9, somewhere in
Mhm.
there, about 9 o'clock, face west.
Now, what we're going to talk about is the twin stars, Castor and Pollux.
Mhm.
This
Okay.
is Castor and Pollux.
Mhm.
The
Nice
twin.
orange star. This is, whoops, I just closed that application. Huh,
Now, this doesn't mean it's Gemini. We're talking about twins, right?
it is.
Yes.
It's the heads of the twins, Ron.
Oh, it's the head. Oh, okay.
Pollux is on the left and Castor is on the right.
Mm-hmm.
Now, Pollux
Stunning.
is a multiple star system,
Mhm.
6 of them.
Yep.
6 of them. We covered that before very briefly, but reviewing never hurts. So this is the total effect of Pollux. It has you can see this component, which is one, and this component, second one. But to go deeper than that, you can't separate them visually. So, although this is separation 3.9, yeah, between these, you can separate these visually. Here, the separation 71 minutes between these two. That's quite a bit.
Yep.
I think this is 3.9 minutes. Looks like, yeah. So these are easy, but you can't separate this by this and this from this and this from this. Visually with any scope, you have to look at it with a spectroscope, and you see the lines move as the star swings toward you, and the spectral line moves to the right or moves away from you, and the spectral line moves to the left. The spectral lines split because one is moving towards you, the other one moves away from you. And so one line is red shifted and the other line is blue shifted. And sometimes that just makes a fat line, but usually it separates into two lines. And that way you can tell it's called a spectroscopic binary.
Hey, Jerry, your little red asteroid is still in this image too, in the lower right. I wonder where that's coming from.
Uh-oh.
A quick question, Mr. McPartland.
Yeah.
When you occult an asteroid as big as Ceres, you got a few seconds, if not a minute or two, before it lets the star come out, right? Because of its size.
And for Kuiper belt objects, because of their slow motion, you get really long occultations too.
Have you ever occulted Ceres?
No.
Okay. So this 6-star system that I'm trying to catch up with that we're watching here, is it similar to Alpha Centauri? Isn't that, well, that's 3 system, that's 3 stars, but what do we got? 3 pairs orbiting, and somehow the orbiting pairs go around the other orbiting pairs?
Yes.
Yeah, it's also very a hierarchy of common rotation centers.
That's
So,
all?
okay, so here's the question for this minute. What's the temperature of Castor and what's the temperature of Pollux, surface temperature?
Castor is a lot hotter.
Yeah.
Yep.
So Castor is blue.
Mm-hmm.
So its temperature could be anywhere between 25,000 and 60,000.
Mm-hmm.
And
Well,
Pollux
now, but
is
Yellow.
It's 6 stars, so which one of them are we talking about?
well, you're seeing the aggregate of all of them as a single star. You
I
can't
know that,
separate.
but does their heat intermix?
The light intermixes, but the stars don't intermix.
Well, it's got to be the heat.
What you're getting at is right. There's no single surface temperature, but these stars are all about the same kind of temperature.
Mm-hmm.
And so this is a real live color. This is the way it would look in a telescope. A little
Yes.
bluer on the right, a little cooler and redder on the left.
Yep, exactly.
Pollux.
Mhm.
And
And
Tim,
that-
our favorite star hopper, says Pollux is closer to Procyon and Castor is closer to Capella. So you can tell which
Okay.
is which.
And those are
Okay.
those are the Gemini what? Heads or eyes or?
Their heads.
Okay. This is the sun compared to Pollux.
Yes, this is Pollux,
The big one.
the big one compared to the biggest one in Pollux compared to the sun back here. And you see the color. This is a false color. It's not a photograph. This is a drawing, a sketch, but the color is right. Our sun is yellower, so it's brighter. Pollux is cooler, it's oranger.
Really? Only by
Okay.
the law of God did we not become a binary with something like that. And our sun, with us orbiting it, would be orbiting Pollux. Wouldn't that be a life?
I think growing up on Tatooine would be really cool.
Okay,
Okay.
fascinating. I love this stuff. This astronomy is just so fascinating.
Now this, we moved ahead a day, midnight at May 11. This chart will not change this week. It'll be the same, except these constellations will be a little higher each night. This is looking in the southeast. And this is the rise of the first of these summer constellations, Scorpius, Sagittarius, and whatever the other one is.
Ophiuchus up there, Libra.
Yeah.
We don't see them for months during winter.
No, there, the sun is basically obscuring these things
Oh,
in the winter. These
Yeah.
things come up, and this is looking at the when the Sagittarius is up, which is following Scorpius. That'll be
Right.
the center of our galaxy that we see.
Yeah. Around
here-
midnight, you can see this. Around midnight, you can see this almost due south.
Yeah.
Midnight, 1 o'clock, somewhere in there. I did.
And it's something on the order of a month that they're too close to the sun to see, but then if you get up real early, you start seeing them.
well, do we see them on the ceiling of the planetarium,
Sure.
even though
Yeah,
it's summer?
She can put anything, Chrissy can put anything anywhere on the planetarium. So
Now, isn't there a summer cross? What is the cross thing? That's
summer triangle.
there's a summer triangle. Is there a southern cross?
There's a Southern
Yes.
Cross, but it's not visible from our latitudes.
Okay, so we'll
But
never see
maybe
that.
not
Chrissy
that.
can, of course, change the latitude we're at.
Right, we can look at it in the planetarium. It's not that dominant. It's a teeny little constellation.
It's the smallest constellation.
Really?
So anyway, what we're looking at here is the claws of the scorpion that's coming up. You can see, well, I can't pronounce that, Acrabrephius up here.
Mhm.
And
Well, those are the new claws of the scorpion.
Right. Yeah.
The ones up there, you can see Zubin el Janubi, and there's also Zubin es Shamali, which I think is
Yeah.
just off the top.
yeah,
Yeah.
Those names mean southern and northern claws of the scorpion. They used to belong to the scorpion, but the Romans stole them to make Libra.
yeah.
Yeah.
This gerrymandering is getting out of control.
Yeah.
There's Antares in the middle of
Yeah.
everything.
So anyway, the most prominent star is the anti-Mars here, Antares. It's red, just like Mars is. And there's two, I guess, three very nice globular clusters in here.
Mhm.
This one is pointed out, the red,
Yeah. 6144.
it's the,
Looks like 6144.
yes.
Yeah.
Yeah,
It was
that's,
really neat story about that. He used to tell at the workshop. So when he was young, he used to look up into Scorpius. Of course, you'd easily see M4. And when he and his friends saw this other faint thing near M4, they thought it was a comet. But it's just another globular cluster.
yeah. It's not a very dramatic globular cluster. It's not got a
It's
real,
tough to pick off. Yeah.
yeah.
Hmm.
So this is NGC New General Catalog 6144.
Hmm.
It also has near it M4, which is just off of
Antares.
Antares. That is a very dramatic M13 type globular cluster.
Mhm.
And there's also M80 up here. Another
And you know
globular
that
cluster.
propeller feature in M13, there's a feature in M4 that looks like a dark line elongated in the center. So it's often called the cat's eye because it looks like
Oh,
an
okay.
elliptical.
I should have put a picture of that up, but anyway. So these are neat things to see, and they're harbingers of the summer's great dramatic constellations.
Wow.
This is the densest it's coming up is the densest region of the Milky Way. You don't see a lot of galaxies here because they're obscured by our stars, but you see a large number of open star clusters, globular clusters, and nebulae, both bright and dark, red and blue.
Hmm. And Antares means anti-Mars, anti-war. I never thought of that,
Rival of Mars.
Right.
but it's a star, not a planet, but that's
Right.
okay. Here we go.
Oh,
What
it's
is-
red.
Oh, it's red. That's the reason. Okay.
And often Mars is in its region, you know.
Is this the supernova remnant?
This
19
is an artist representation, not a photograph,
Hmm.
of a supernova 1987A,
Ooh.
looked at from the side. We saw this in where was that? It's in the Large Magellanic Cloud, which you can see from the southern hemisphere in
Yes.
February 1987. And what's going on here, there's a complicated set of dynamics going on about stuff that was thrown off before the nova exploded it was, or the supernova exploded. There was some activity that threw dust off. And then the supernova exploded, and the explosion remnants collided, caught up to and collided with the expelled dust and created some of these structures. A lot of the structures were created by most likely an asymmetrical explosion. That is, the explosion was not spherically symmetric. It didn't come off like from a point up to a sphere. It erupted out of one side, kind of like Mount St. Helens blowing up. It didn't come out the top. The side of the mountain fell off and it blew out to the side. So that's where you get these different structures from, is the non-asymmetry.
Has the word hourglass been applied to a nebula or a galaxy? Because this
Yes.
looks like it has. There is an hourglass something out there, isn't there? Because that's what this looks like.
Many things qualify.
Yeah.
Yeah.
Or
Dolly
butterfly.
Parton. Okay, could be a Dolly Parton undergarment. Never mind. We're not.
Okay, we're moving on.
Right.
Okay, now,
We are on the moon.
wait a minute. Okay, there we go. I put it this way in the talking points, and then when I sent it out, it turned it around. And the reason I did this is so it would line up with this map, which has labels on it. So this is the crater Archimedes, and this is whatever
Autolycus.
thank you. Aristillus, Cassini, and up here at the top is Plato. So
Plato's got his name
This
on a
is-
crater.
this is a very dramatic view. Is this the Hadley Rill?
No, that's that Apennine Valley or
That's,
Yeah.
yeah, that's right.
Valley.
That's right.
Yeah, Valles Alpes.
yeah, Alpine Valley.
Mhm.
Imagine we've landed.
Yeah,
some
Valles Alpes up there in blue. I missed it. Okay.
My
So
question-
this is a very nice picture taken at about the time when the terminator of the moon or the thing went down there, about last quarter. And that's about what we're at this week, will be the last quarter. Right now, I think we're 3 days after full moon, so it's a gibbous face, so you won't be seeing this yet for a few days yet. But this is very neat down here, this crater. You can see all the little jagged spikes in the shadows that represent peaks on this rim.
Mhm.
And they're on a roughly flat floor, because whatever did the flat floor out here did it in here too. So this crater was likely there before the lava came up and filled everything. This crater, because it's got splatter effects and ridges going out from it, this happened after this floor was flattened.
Mhm.
Right.
So
And actually, the smooth one there, that's actually a pumpkin pie somebody left up there.
this one,
Oh, down the original flat floor down there.
Oh, Plato.
Yeah, Plato. Up.
yeah,
I missed the name of the mare, the sea that we're in the middle of there. You gave it. Where are we? Tranquility?
then it's
No.
Lunatics, the Bay of Lunatics. Anyway, no, I don't see a name of that.
Prosalarum, or I'm
Yeah,
not up on my oceans on the moon.
yeah.
Well, I'm wondering
But
if
down
Matt-
right here, it says Apollo 15.
that was going to be my question. Is there a map showing where all the Apollos, in fact, all the landers and even the ones that have crashed, though we can't see them? We
Well,
know-
in our
It's right-
handouts at outreaches every month, we have a map of landing sites on the moon where you can
Yeah.
see some of these.
We can
Really?
get that.
why
So
don't you
Apollo
show-
15 landed right here where the cursor is.
No kidding. We left behind the launch part of the LEM. It stayed
Yeah.
behind. Can't be used again, or maybe we can
Someday.
grab it again.
Someday it'll be a theme park.
And I think that was the first mission that had a rover that had the car.
Oh, a car?
Yeah.
How in the devil do they test those? They'd have to test it somewhere where there's little gravity, no air.
They give
No,
up on the gravity in the air. They just test it out on a sand dune.
they tested
Really?
it out here in Goleta at the. It's too bad that we lost Bruce, but he was probably part of that. I mean, he worked on the lunar rovers, on
Well,
the
his friend-
cars.
Yeah.
A friend of Jerry's is going to be one of his old buddies in August as our speaker. What's his name?
Peter Love. Peter
Yeah.
Love. He's a
And he was
PhD
out
in
there.
physics from UCSB, and he worked on our company worked on the James Webb Space Telescope mid-infrared sensors, and Bruce and another guy were the guys that specifically worked on the sensor. So he's going to give a talk about that sensor and its technology.
Actually, you said Bruce, but I don't think you meant Bruce.
I said Bruce.
Yeah,
I meant Peter Love is going to
Yeah.
talk, and his friend Alan Hoffman.
Are we talking the 70s? That would be 50 years ago.
no.
that would be-
This is now we're
this
talking
was-
James Webb.
Yeah.
I know that, but the web was launched 2 years ago and 21, and that
Yeah,
would have been 40 years after you're working on its camera.
Okay.
no, Ron. These people worked on the James Webb. It was Bruce that worked on the lander.
Yeah.
Well, okay. Well, but I talked to Jerry's friend, and I think he told me that he worked on something for the MCR, whatever the name of that.
Yeah,
That's
near
the
cam.
Yeah, the MIRCam on
MIDI, yeah.
James Webb. The
I know
camera
that.
goes on
Or-
James Webb.
Okay.
Our company made instruments and components for instruments, and the instruments we made were imagers, spectrometers, polarimeters, and sounders. And so
We're
they're
talking-
on various they're on various satellites like orbiting Mars and chugging around on Mars' surface. But we
Oh.
didn't make the spacecraft itself. That's a higher level integration than us.
Okay, so we've had those cameras for quite a while, and they just happen to be on the web.
They were custom cameras, and we started working on the James Webb in the 1980s, and it was
Yeah.
due to be launched in the late 90s. And when they actually launched it, that was delays in funding, delays in overcoming, because a lot of the technology is new. And so we had to develop technology and then prove that it worked in independent packages before we could put it in James Webb. That just took a lot of time. And the bureaucracy of NASA took a long time. Sorry. NASA.
Back then it was only $1 billion. Guess what? It's $10 billion out there now.
Yeah, I think it went up by a factor of 3.
Wow. That'll be good. And then we've got Professor Antonucci this coming June 2nd.
Oh, good.
Will visit us.
I remember him.
Mhm.
Oh, he talked to us before?
Yes.
So-
Well, he was the one that said yes, and that's when I asked Chuck, who do you think we should get? He said, get him, and we got him.
Yeah, he's good.
All right, so the
He did.
Terminator.
He also sent out a PDF of an article he wanted everybody who came to the meeting to read. So I don't know how we're going to do that.
You mean for the new one coming up?
Yeah.
Oh, good. Send it.
You suppose Lubens is that his name? The one that wants to send the postage stamps out to Alpha Centauri or Proxima?
He's busy.
Yeah, Phil
busy,
Lubin,
busy.
he's still there. He has the coolest name for a investigative group out there. It's called experimental cosmology. Normally, you think of all things astronomic as you're just sitting here with a telescope looking at things.
Mhm.
But
Well, we
he's
had a grand
actually-
time Friday night, and boy, we really filled yeah, I mean, if we went from 85 a month ago to 100 and something, we're going to have to move. We'll see what happens
Yeah,
as we continue these Monday morning get-togethers. Number 117 will be next week.
yeah.
And it should be the 17th? That'll be the middle of May. Gentlemen, take care of yourselves and your wives. And remember to wear those COVID masks on the bottom of your face to cover that damn rooster craw we're all getting, damn it. And once again, go to SBAU.org and join us on Monday mornings for the SBAU Astro Hour at 11 a.m. Thanks. Appreciate it.